Okay, next up we have Cam Fiss. I guess that works. Avian communities associated with Central Appalachian Forest enrolled in NRCS, Working Lands for Wildlife. Cam?
Just when you all thought we were done with birds here. Yes, thanks Charlie for setting up the symposium, and thanks everybody for attending. I'm going to build off a few talks that we saw earlier. Jeff Larkin and DJ McNeil talked about Working Lands for Wildlife projects for golden-winged warblers. And then Cody just now built on that with how pollinators are also benefiting from that habitat management. So now coming back from pollinators back to birds, we're going to look at how another indicator of healthy ecosystems, how they're also benefiting from golden-winged warbler management under Working Lands for Wildlife. So I'm sure none of you have seen any of this yet. But seriously though, these are results from the Rosenberg science paper suggesting strongly that North American birds face a conservation crisis. 3 billion birds across North America have been lost since the 1970s. And what's conservation scientists have learned, and what this paper really underscores, is that management needs to focus on communities, and single species management, which doesn't stand to benefit multiple communities, is not going to help reverse these population declines. So this 2.9 billion birds is across North America. We're going to focus in on these eastern forest birds, which have declined by 17% in this same time period. So we can't discount the effect of human land use converting forests to other land use types. But to really understand why birds are declining in our eastern forests, we have to go back about 120 years to when wide-scale clear-cutting occurred throughout the Northeast and essentially erased hundreds of years of structural diversity and age class diversity all at one time. What we're left with is a landscape that is very homogeneous and is dominated by one land age class type. So this is the distribution of forest age classes in the Northeast currently, and as you can see, it's strongly distributed into this 70 to 80-year-old age class. We have very little young forest on the landscape, and we have very little old growth forest on the landscape. But in addition to the lack of age class diversity, eastern forests are also simplified within. They lack structural heterogeneity in the understory. And this is due to a number of factors. Overbrowsing by white-tailed deer limits the regeneration success of a number of species. Invasive pests have removed a number of high-quality tree species from our forests. Unsustainable harvest practices, including high grading, which often occur on private property. And then, of course, the removal of natural systems like fire, which would help regenerate these forests and create the structural heterogeneity. So we have two big things going on. We have this loss of age class diversity, and we have this loss of structural diversity. And this loss of age class diversity in particular has demonstrable effects on particular avian communities. So in particular, the early successional nesting birds pictured here have experienced long-term population declines. So about 71% of those species have been declining since the mid-1960s. And then we add on to that all this recent science which has been done showing how the lack of structural heterogeneity influences breeding birds regardless of their nesting guild. So whether you nest in an open understory mature forest like the ovenbird, or whether you nest in mature forest with perforated canopy, during the entire breeding season, nesting to post-fledging, these birds end up using diverse forest conditions, whether it be denser understories or younger forests. So unfortunately for conservation biologists and land managers, conservation dollars are very limited. And so it's not practical to create best management guidelines for every single species that's declining or to implement management for every single species that's declining. But it does make sense to focus in on one of these species that is undergoing some of the most rapid population declines, such as the golden-winged warbler. Jeff and DJ talked about this species. I don't need to go into it anymore. But it makes sense to focus in on one of these species with highly specific habitat needs that could act as an umbrella or a surrogate species for the rest of the avian community. So we wanted to see if the work being done by Working Lands for Wildlife translates into conservation success for the avian community as a whole. So this is the distribution of all the points we visited between 2015 and 2019. All these yellow locations are Working Lands for Wildlife overstory removals. All of the red locations are shelterwood harvests under the RCPP program. And we supplemented these private lands managed areas with the blue dots. And those are our reference sites, essentially. Those are unmanaged forests, which represent the current matrix of our northeastern forests. So Jeff and DJ also talked about this, so I'm not going to spend a whole lot of time on it. But we essentially conducted unlimited radius point counts, and these were 10-minute point counts where we recorded every species heard. We visited the locations twice per season to account for detection probability. And that season ran between 15th of May and 15th of June from 2015 to 2019. And again, we visited these sites enrolled in Working Land for Wildlife, which had undergone overstory removals, visiting the same sites multiple years in some circumstances. We visited the RCPP sites that had the shelterwood treatments. And finally, we visited nearby public lands, mostly Pennsylvania Game Commission lands and Pennsylvania DCNR lands, to get that reference avian community. For our analyses, we used linear mixed effect models to look at species diversity in sites. We looked at how a few things, including management type and year since management, how well that predicted the species diversity we might see in a given treatment area. And of course, we used site as a random effect to account for the fact that we visited some of these places multiple times over different seasons. And then to look at the abundance in these areas by focal species that we were interested in, we used the Royal Nichols model, which actually uses occupancy data, but it uses the information in detection probability along with occupancy to derive abundance. So this is just some of our overview results. We did 1,212 site visits from 2015 to 2019. And that included 726 unique sites across Pennsylvania, New Jersey, and Maryland. We visited 305 Working Lands for Wildlife sites where overstory removals had been conducted. We visited 88 RCPP sites. And we included 156 public and private unmanaged reference sites. For one of our analyses, we compared how Working Lands for Wildlife overstory removals compared to public lands overstory removals. So we also visited 178 public overstory removals to make that comparison. Overall, we detected 145 species across all sites, and that includes passerines and non-passerines. But on Working Lands for Wildlife and RCPP sites in particular, we detected 106 species of passerines and near passerines. So what this graph is showing in larger boxes is the predicted, or it's just the naive occupancy probability of a given species. So for Working Lands for Wildlife sites, the red-eyed vireo was detected at approximately 90% of sites. And this size of the box is relative for each species. And species with a red box are undergoing population declines. So things like eastern towhee and common yellowthroat, scarlet tanager, whether they're long-distance migrants or just a short-distance migrant, many of these species were found on working lands for wildlife sites, and many of them that occur regularly on these sites are undergoing long-term population declines. So this is the analog on unmanaged sites. Again, red-eyed vireos were very common. This box represents about 98% naive occupancy. So red-eyed vireos were pretty ubiquitous on unmanaged sites. And we still have species that are undergoing long-term population declines, but they're occurring a lot less regularly than they were on working lands for wildlife sites. So to take this a step further, this is the results of our linear mixed effect model where we're looking at the effective number of species on the y-axis, and that is essentially a derivative of the Shannon's diversity index. And on the x-axis, we have our three different management types: overstory removal, shelterwood, and unmanaged forests. And as you can see, there's a pretty significant difference between species diversity that we saw on overstory removals versus the shelterwoods even. And then there was even a small difference between the shelterwood harvest and the unmanaged harvest, or just unmanaged sites rather. So this model had pretty good predictive probability. This is actually delta AIC. But we suspected that there may be something going on and not just a difference in site itself. There could be an effect of the site across growing seasons. So this is actually an interaction of the treatment types with the growing seasons on the x-axis. And again, on the y-axis, we still have effective number of species. As you can see, the overstory removals decline slightly in the number of species. And I think this gets at kind of the ephemeral nature of this habitat. I'll talk a little bit about that later. And shelterwoods were pretty continuous throughout the 6 growing seasons that we had monitoring data for. And then the black line here indicates our unmanaged reference sites. So again, we still see this effect where overstory removals have the greatest amount of species diversity. And with the interaction of growing season, this model had the best predictive capability. So another important thing we wanted to look at was how did working lands for wildlife compare to kind of a gold standard of overstory removals that we see on public lands in Pennsylvania and Maryland. And we were pretty pleased to see here that there's no real significant difference between species diversity on a timber harvest done on private lands by working lands for wildlife versus a timber harvest that's done on public lands by our state officials. We also wanted to see how a site that achieved golden-winged warbler occupancy would affect the effective number of species size, and how that can be used kind of as a surrogate species to predict the diversity of species we might see on a given site. And this was a very strong relationship that we saw where, as we saw more golden-winged warblers on a site, diversity, community diversity also increased. So this is looking at the Royal Nichols model and comparing abundance of several focal species on unmanaged sites, on shelterwood sites, and in the overstory removals, so RCPP and working lands for wildlife. Most of these species that we took here are from the Pennsylvania State Wildlife Action Plan and their species of greatest conservation need. They're justified on that plan based on their population status, the trend, and whether they occur regularly in Pennsylvania. So you can see there's a pretty stark relationship here for eastern towhee and chestnut-sided warbler and common yellowthroat. So 3 of these species which nest in early successional forest, strongly benefiting from working lands for wildlife. And even species here such as wood thrush, which has historically been associated with mature forest. It's not more abundant in overstory removals, but it's surprising to see that it still occurs regularly in these sites. So several more species here from the State Wildlife Action Plan. Field sparrow, again, occurring almost only in working lands for wildlife sites. Prairie warbler, same sort of thing, where it's almost exclusively occurring in those working lands for wildlife sites. The black and white warbler, again, is a species that may be more associated with mature forest. However, that's also not less abundant than, or it's slightly more abundant in overstory removals than it is in unmanaged sites. And then finally, the gray catbird, also benefiting from working lands for wildlife. So what our results show is a pretty good indicator that golden-winged warbler can be used as an umbrella species to predict the conservation value of certain areas. Approximately 20% of the species which we found in working lands for wildlife sites are experiencing long-term population declines. Many of these, of course, are this early successional guild that we see here. But species that also nest in mature forest are also not negatively impacted by management, overstory removal management. And this is interesting based on this new science that's come out in the past 20 years showing that mature forest species can also move throughout the landscape during the breeding season and may require younger forest age classes to complete the full breeding season. What this also shows is that there is a pretty huge level of importance for private lands in conservation of the avian community. Approximately 85% of eastern forest bird distributions occur on private lands only. So this really, it suggests that scientists need to not just create collaborations among themselves, but they also need to work with land managers and, really importantly, with private landowners to benefit these species. And as we've seen kind of in the last 3 or 4 talks, this habitat is ephemeral, and it's going to take continued management to continue seeing benefits from these practices. Finally, I think it's important here to point out that the oldest working lands for wildlife overstory removals in Pennsylvania are only about 6 or 7 years old. But as these continue to regenerate, they should provide high-quality mid-successional forest for other species which are undergoing population declines. So some of the future directions we want to go with this analysis, we're interested in modeling the entire bird community using these Royal Nichols models and incorporating all these vegetation characteristics that we recorded through the golden-winged warbler monitoring and seeing how those might influence species individually throughout those treatment areas. With that, I'll thank all the contributors and partners, and if I have time for questions, I'd be happy to answer those.
You do? Questions for Cam?
Yes.
Do you have a sense what the historical disturbance regime is? That a tree fall gap sort of historical disturbance regime for those forests?
Like what may have created those?
Yeah, like the birds may be adapted to some sort of historical disturbance regime, and management might be mimicking some kind of historical process.
So, so specifically for tree fall gaps or for larger areas?
Yeah, I'm just curious what the historical.
So there's a number of things. Fire is typically mitigated in eastern forests when that occurs. Beavers, which would create a lot of tree fall gaps through creating meadows and such that no longer really occurs because beavers have been removed, essentially. So I think those are a number of things.
All right, thanks, Cam.
Yep, thank you.